Good afternoon and welcome to the third installment of the video series that is accompanying Oakland's How to Build a Data Platform guide. We have got an extensive guide for you that tells you from soup to nuts how to build a data platform for your complicated enterprise. And the link to that guide is down there in the comments. But this is episode 3, and today we are going to be talking about solution architecture. My name is MLG, and before we get started, I'd like you to do all that normal YouTube stuff of liking, commenting, subscribing, and so on. That would mean a lot to me and mean that we can make many more of these videos together. But today, let's talk about solution architecture. Now, there are people wandering around on this earth whose entire job is solution architecture. So if you have one of those people, if you have a solution architect, this is the moment to engage them. Because what we're going to do before we do anything is we're going to lean back and think big questions. This is not unlike that moment when you start a band. I don't know if you've ever started a band in your life. You should. It's a fun time. But when you start a band, before you start making music or thinking about what effects you are wanting to use or the pedals that the guitarist has or anything like that, the first thing you do is you sit down and you think about your influences. You think about what kind of music are we actually going to make here? Like, what do we want to achieve with the sort of music that we're going to make? And when you design your solution architecture for a data platform, that's not unlike that moment. We're about to step back and think about the big questions, like how much money do we have to spend on this data platform? Should we be going cloud or on-prem? Do we want to buy a solution or do we want to home grow stuff? Do we have data that we want to migrate in? What are the bounds of the problem that we're actually trying to solve? And how, at the end of the day, do we know that we've got value out of our data platform? And if that's a question that's troubling you, then you should go back to episode 2 because we talk about that there. So today we're going to take ourselves a deep breath and think about 2 aspects of solution architecture. Next week, we're going to think about one more of them. But this week, we're going to think about the choice between cloud computing and on-premise solutions. And then we're going to talk about something called data mesh. Next week, in episode 4, we'll think about data processing and the different kinds of databases that you can have and pipelines that you will require. But today, we're going to think about cloud computing and data mesh. So one of the first decisions that you've got to make when you build yourself a data platform is, are you going to go into the cloud or are you going to stay on premise? Now, cards on the table. I am a cloud developer. So I'm going to tell you that in general, there is a cloud component to be had of your data platform. And I'm not alone, right? If you look at the market trends for the last 15 years, the trend has been towards going to the cloud. But we need to remember at all times that this is effectively a choice between buying your own computer and servers or renting somebody else's. And this is not a place for us to have a really in-depth discussion about whether you should go to the cloud or whether you should stay on premise. That I will leave to you. And if you would like a discussion like that, then hell, get in contact with us. But it's worth a quick rundown of the benefits of each of them. If you're on premise, say, and you buy your own hardware and then you run your data platform software on top of that, then it's yours. It's secure, it's private, the costs are known and controlled and well understood. Whereas if you go into the cloud, you don't fully understand all of the time, all of the costs that you're going to incur. But as part of that, you can effectively rent these things by the second. So you don't have a fixed cost, but you might have a significantly lower one, especially if you still have to do things like turning your cloud infrastructure off at night or scaling it when people aren't using it. Equally, it can be more secure because the big 3 cloud providers, Google, Azure, and AWS, they provide very secure connectors to all of the cloud software and infrastructure that they have been developing over the last 15 years. And you have a direct upgrade path. If you start using something like Azure Data Factory to ingest all of your data, Azure Data Factory is going to receive a whole bunch of updates over the course of the life cycle of that project. And so you will always be reasonably sure that you're on the best and greatest software and the most secure connectivity that you can be. Whereas if you roll your own on-premise thing, you have to manage that upgrade path yourself. So this is a choice that you have to make for your data platform. But then equally, you need to make a choice about how much command and control you want over your data platform and who has that command and control. The data platforms that we've been talking about so far have been what we might call a centralized one. When you and I draw a data platform, we do something like this. We say, well, we've got some kind of central storage component in the middle. And this is a diagram that you will be familiar with from our first episode. We have some kind of storage mechanism here, and then we have an ingest mechanism over here. And then we have our serve mechanism all the way out here, whatever that might be. And in the normal case of events, or in at least the most simple form of events, this is centralized. And you have one data team, one data central function that manage this process. And if you are somebody else out in the enterprise, what you do is you come along and you say, right, my department, let's pretend we're making cars, say, okay, and I run a department that makes some component of the car manufacturing process. And I make that component and I produce data, and I have some KPI that I need surfacing onto a dashboard. Say the tolerances and how many of them we throw away, something like that, for this component. And in a centralized data structure, I come along then to the data team and I say, right, look, I've got all these machines out here, these manufacturing machines, and they produce some data, and that tells us like how many of that component we're throwing away. And what I really want is a Power BI dashboard that tells me that KPI week on week, say. So I want to know if the number that we're throwing away gets to be more than 5% of the product that we're making, then alarm bell should go. We need to reformat the process, get some new tools, yada, yada, yada. Whatever that happens to be, some well thought through KPI. And so then the central data team come along and they say, right, well, okay, let's connect your machines up to the ingest process, whatever data feed is coming out of here, and then we'll surface that in the storage. We'll do like medallion architecture, bronze, silver, gold, and then we'll pull it out into a Power BI dashboard for you to consume. That is a centralized structure. And for teams where you can count, you know, like one reasonable human can count the number of data sources that you have, this is great. This is wonderful. But like most things in the universe, the first way of building something, or the first thing that you think of as a way to solve the problem that you have, is not necessarily always the best one. So what happens if it's not just me, right, that has this one data feed? What if we start to add lots and lots of data feeds? So now I don't have one data source that's coming in and needs ingesting. What if I have 47,000 different data repositories that need surfacing in our data platform? Well, now I have like a massive problem on my hands, because my engineering team is going to spend an inordinate amount of time conforming, building, surfacing those data feeds into this one centralized place and serving them out in individual custom things. And eventually people start to decide, well, the SLAs on the data engineering team are just way too damn long. I need this KPI flipping tomorrow, right? So I'm just going to start. Look, it's easy if I just take Excel, connect it to the machine, and just build a graph on top of that. And very quickly, this, in very complicated situations, can federate massively into cottage industries of individual people going, well, look, this is hard for enterprise reasons, not for tech reasons, but this is hard. So I'm just going to make my own Excel spreadsheet just here. And you have all of these tiny cottage industries and shadow IT, this sometimes get called. What do you do then? Well, at that point, we need to lean back a little bit and think of data not as a byproduct of the processes that we do, but as a product in and of itself. And I'm going to talk about something called data mesh, which should inform how you think about how your data architecture and your solution architecture is going to be built for your data platform. There are books and books written on data mesh architecture. So we're only going to touch the surface of what it truly means to have a data mesh today. It is not possible for me in the confines of a 15-ish minute YouTube video to go into truly what it means to embrace data mesh. But I'm going to give you a little bit of a flavor of it so that you can understand the sorts of questions you should be asking and how your solution should be architected. Because when we go into data mesh, we don't think about this data flow as a byproduct of what we do. So we make, as you remember, car components. And in the normal world, we would think of those car components as the first class thing that we do. So I make these little bolts, say, that go into cars. And as a result, I also get some data, but that's kind of a side effect of what's going on. what data mesh philosophy, and they call it like a socio-technological philosophy. It was invented in 2019 by somebody, I've genuinely forgotten the name, but they call it a socio-technological philosophy, which is a very grand way of saying, just rethink what you're doing. Because what they ask you to do with data mesh is to say, the data that your process generates is an equally valid product of what you do than the actual thing that you make. So your output from your machines is not just bits, it's not just valves or screws or whatever I said that it is, it's also data. And both of these are equally valuable outputs. So what does that actually mean to embrace that philosophy fully? Well, to fully embrace that philosophy is to turn this entire thing on its head. So previously, we've been thinking about a centralized data platform where you have a data team that builds the cloud architecture or the on-prem architecture, but remember, I'm biased, we're going to talk about the cloud. The cloud architecture that creates this entire data pipeline. Instead of the data team spending their time running infrastructure as code and building out data pipelines, what the data team do in a very complicated data mesh organization is they set standards and they provide the environment whereby teams can build data pipelines to surface data products to the rest of the organization. And so the data team sit on top of all of this and provide things like the Azure DevOps environment or the GitHub repo or the Bitbucket environment. I don't know if you'd ever use Bitbucket for that, but let's pretend you might. Whereby you can have individual engineers inside these teams build out the pipelines, which then conform to a standard that the data team accepts. So there might be infrastructure checks, there might be quality checks, there might be latency checks, there might be analytics standards that the data team test for. And if you ever make data, what you have to do in the pure form of data mesh is if you make a data product as a department, it is your responsibility and your job to surface that to the rest of the organization by building the cloud infrastructure, by building the pipelines, by conforming to the data team's standards, such that everybody else can then see your data and consume it as a product. Now, in the extreme forms of this, you have individual teams building their own little bits of IAC from modular components that the data team provide and then throwing those into their own cloud environments. So you might have like an Azure subscription for every single department, and each department is responsible for building their own pipelines and surfacing that according to the standards and the quality tests that are prescribed by the data team. And so you highly federate this entire thing into a mesh. You don't have one big data pipeline. You have a mesh of lots of little data pipelines that all have their own little bits of storage, and they all surface into a standardized way that the rest of the business can consume. Now, if that sounds like obvious madness to you, you are not alone. If that sounds like a huge cultural challenge to you, you are not alone. Which is why data mesh has not been as, shall we say, as wildly popular as it maybe once thought it might be. That this thing was launched in 2019, data mesh, and people came out and went, data mesh is the way we're all gonna go. And then everyone looked at the proper implications of what it means to fully embrace data mesh and just were like, oh boy, are we not ready? Because what it requires you to have is it requires you to have every department have an understanding of DevOps practices, of pipelines, of code, of infrastructure, of standards, of testing. And quite honestly, most organizations are not ready to embrace that level of technology in every single department. If we go back to our example of people running machines to make valves or screws or something for cars, genuinely, do you want them to spend their time sat down here maintaining data pipelines as a first-class citizen as well as making valves? Because that's quite a hard sell to your exec. If you sit there and you say, well, actually, we want now every team to spend 50% of their time because the data and the valves are equally important. So they should split their time between maintaining data pipelines and maintaining valves. And so in true data mesh, you suddenly have departments, and every department has a data function, so they need data professionals in every single department, and suddenly we've got a big mess on our hands. So maybe we should do something slightly less heavy-handed. And that slightly less heavy-handed thing is somewhere between a centralized data platform and a full-on decentralized data mesh. Some people call this a data fabric with a lowercase f. So don't confuse this with Microsoft Fabric, the data platform architecture, though there's a good reason that they've called that Microsoft Fabric, because it pulls on many of the threads that, I've just made a pun, I'm so sorry about that, but Microsoft Fabric pulls on many of the threads of Fabric data architecture. I'm so sorry about that. Let's pass over the fact that I made that pun, right? But you could, instead of saying this, so let's get rid of Excel, because we're not going to use Excel. Instead of doing this, where every function has its own data program that conforms to the standards set by the centralized data team, why don't we instead have every department pushing their data into a centralized data repository in a standard way so that it's consumed? Why don't we, people don't have to make their own cloud infrastructure. Maybe we have a central cloud team that builds out infrastructure for them and goes out and helps these people out in these departments pull their data into the central storage location, and then we'll pick it up from there and figure it out going forwards. There's hybrid ways of building out this decentralized architecture, because if you have a quite complicated organization, you're probably going to wind up somewhere in the middle. If you have lots of ingestion that you need to do, then a centralized data repository where you have iron control over every single data product is probably not possible, because it will just take too long. You'll have to hire 2,000 data engineers to have any kind of acceptable SLA on your pipeline creation. And obviously that's not going to work. So in small scales, centralized data repositories, centralized data platforms, great. If you have a highly advanced, highly technically oriented organization with thousands of data feeds, then data mesh might be the way to go. So I'm thinking like Netflix. Netflix are reasonably notorious for having embraced data mesh quite wholeheartedly, because they have a highly code-aware data workforce. That's not always possible. If you've got people out here running stamping machines to make valves, they're not interested in IAC and Terraform and things like that. So the answer is almost certainly somewhere in the middle. But by designing this platform and understanding where your data flows are going to come from, and figuring out who has the final word on whether data is accepted into your platform or not, by doing that, you can start to think about the kinds of infrastructure and the kind of platform that you are designing. And that is hugely informative for the solution architecture that you are creating. These are the big questions that you need to ask yourself, because by answering those big questions and understanding where the value comes from your data and how people are going to consume it, and not only the technical bottlenecks that you are going to approach, but also the enterprise bottlenecks, so things like politics and culture, and how are they going to integrate alongside your data platform. Those are big things that you should probably answer before you build out a massive data platform and invest a whole load of money into it, because we really don't want you to build a huge centralized data platform where you have iron control and high quality data because it is manually checked, or it is definitely run through a DevOps environment by a data team. But then nobody uses it because it just takes too damn long. And so we just get this highly federated Excel-based workflow in cottage industries. But equally, you shouldn't probably run to the other end, where you have data mesh and people who've been working on PLCs for their entire life making car parts suddenly are expected to be able to master cloud infrastructure, because that isn't going to work either. People will just ignore you. So what I want you to do is understand the processes that you're going to augment and how that data will bring value to people, and ultimately, where is it going to get served? Like, what is this what is this cycle, this acyclical graph? What does it look like, and how does your business interact with it? And only when you've answered questions like that should you then think about putting your fingers to the keyboard and actually specifying what resources and stuff you want. If you've got questions about any of that, then please reach out for us. The link to download the data platform guide is in the description of the video just down below. And our contact details are on the website that link takes you to as well. I'd love you to like the video. I'd love you to comment if you've got feedback. If you think I've explained data mesh wrong, or you think that centralized data platforms are the way to go, then please tell me in the comments. I love the feedback that you guys are giving me out there. Subscribe to the channel, download the data platform, and I shall see you next week for data processing.